Hello, you're welcome. All right, so now we're going to continue from where we stop. Okay, so in this tutorial, we're going to be looking at initial value problem of ODE, right? Okay, so now what is the initial value problem, right? Now, you know very well that for us to be able to solve ODE, right? Let's say you have, let me give you a simple ODE, y prime, okay? Uh, okay, let's say a function of x, right? Now, for you to be able to solve this ODE, you will really have to integrate both sides, okay? You have to integrate both sides. Anytime you are to solve ordinary differential equation, you must actually employ integration, all right? And if you must employ integration, definitely you will arrive at constant of integration. Okay, so which simply means that if I'm integrating, this is something as writing the y all over the x, right? Or being f prime of x. So for me to solve this OD, you know what I would do? I have to separate the variable that is f prime of x, okay, the x. Then I have to integrate both sides. By integrating both sides, I'll have y, right, at the right hand side. Then of course, when I integrate this, okay, let's see, if I integrate this, I'm going to have another function. Let me call it g of x, right? Okay, then you know very well that you must definitely introduce c, okay? So now, this particular equation, okay, is not complete. This solution is not complete unless you find the value of the constant of integration. So initial value problem, okay, a problem in which, okay, an initial value of the OD is given, okay, that will help us actually find the value of the constant of integration. So we use initial value problem to get the constant of integration of any ODE. So anytime you encounter a question where an initial value is being given, okay, of a differential equation, you know that initial value will help you find the constant of integration. Okay, hope that is well understood. I will actually illustrate that using an example. Okay, I'll pick a question now. Still a question that is still based on separable ODE. I'm gonna pick a question, then we'll solve it. Okay, I have a question here. I'm gonna pick this question from a book, right? Okay, here we go. So I bring it to the screen. So find the general solution using this. Okay, so let's say we have this particular ODE, okay, and of course an initial value problem. Okay, let's say given that y of 0 is equal to 1. This is a way of expressing initial value problem. Okay, remember y here is the y in this particular function is the dependent variable. So when you see me writing y of 0, okay, so it simply means that it's something as to expressing y as a function of x, right? Y of x is equal to 1. So that simply means that x now, this means that anytime x is equal to 0, then y is equal to 1. So that is what this initial value problem is. So after solving this ODE, okay, I have to actually substitute the initial value to help me get my constant. All right, so now let's say let's now solve this ODE. So I'm having y prime, okay, being equal to x squared, open bracket, 1 plus y squared. Okay, now you know how we do this. Okay, so we can write this now in full, which of course is dy dx, right? is equal to x square, right? And open bracket 1 plus y square. Okay, so now I need to separate variable, but first let me cross multiply. So that means dy is going to be equal to, okay, x square, right? And multiply by 1 plus, okay, 1 plus y square, then ds. So to separate variable, we know how we do that. The functions of y goes to dy, the function of x goes to the x, right? So I'm gonna have 1 all over 1 plus y square dy, okay, being equal to x square, right, the x. So of course, the next step, I have to integrate both sides. And of course, I've integrated this before. So the ones, if you want to integrate this particular expression, okay, the integral value of that gives you tan inverse of y. And of course, for y, we don't add constant of integration. Then for this, we have, okay, x raised to the power 2 plus 1 all over 2 plus 1, right? Then plus c. All right, let's proceed. So this is gonna be equal to tan inverse of y, okay, is equal to x cube, right, divided by 3 plus c. So invariably now, okay, to get my y, you know how good. If tan inverse of y is equal to this, definitely y now, okay, for me to have y, it's gonna be tan of this, or better still, can if I want to get y, okay, for me to eliminate tan inverse, okay, I have to use tan, so I have to find the tan of both sides. So it's something as saying, okay, I want to get y, so I have to do tan inverse of y. And of course, the same thing happens to the right hand side of the equation, okay? So that's going to be 10. All right, for x cubed all over 3, okay? Then plus c. All right, so then cancels tan inverse, so you now have this y now becomes, okay, tan of x cubed, right, all over 3, okay, then plus c. Now this is the general, say, call it the general solution, but the particular solution, okay, is found if only I know my constant. It's just a general solution because I still have this constant c being unknown. All right, so how do I get this constant? By using the initial value problem of, okay, y s is equal to 0 and y is equal to 1. So that's what I'm going to do now. So when s is equal to 0, y is equal to 1, right? That's going to be 1. Okay, then I'm having tan inverse, okay, tan, sorry, not tan inverse, tan 0 all over 3, right? Okay, then plus c, which of course you know very well that from what we have, okay, this 0 over 3, then of course that is 0, so I'm left with just tan c. So that means tan c, okay, is equal to 1. Alright, so invariably C now becomes the tan inverse of 1. C becomes the tan inverse of 1. And of course, when you do tan inverse of 1, you have 45 degrees. So the C, I've got my C, which is 45 degrees. So I can now write the actual or the particular solution of this, right? Having gotten my C, that means the solution to this equation, right, is gonna be equal to tan, okay, s cube all over 3, then plus 45. Okay, I could actually write that in radians. Let's write it in radians. Okay, 45 in radians. Remember, 180 radians is pi, 19 radians is pi all over 2, 45 is pi all over 4. Okay, so this is pi all over 4. Okay, I hope I'm not mistaken. Yeah, pi all over 4. So pi all over 4. So this is initial value problem, and that is how we use the initial value problem, okay, to solve ODE. I'm gonna still solve another question, okay. I'll still bring another question. So here we go. Okay, I have number 8, right? Initial value problem. Okay, that's an initial value problem. Okay, let me start with number 7. Start with number 7. Okay, so in this case, you know what I would do here. Of course, the initial value problem is y of 3. Okay, the initial value of the expression there is y of 3 is equal to 4. So now that simply means that when x, okay, is equal to 3, that's y is equal to 4. Here we go. So now let's solve. Let's solve this. So this is gonna be, you know what I would do? Okay, I have to take plus x to the other side of the equation. So I'm having y prime y, right, is equal to x goes over because minus x. Okay, and of course, if we should write this, okay, in this form, you can write this in this form: divide x. Okay, then multiply by y, right, is equal to minus x. And of course, if we cross multiply, okay, if we cross multiply that, we're gonna have dy to be equal to minus x. Oh, please pardon me. Okay, I'm gonna have, okay, y dy, right, equal to minus x dx. So I can now integrate both sides. So if I integrate y, okay, you know very well that I'm gonna have y raised to power 2 all over 2. Okay, y raised to power 2 all over 2. And of course, if I should integrate minus x, I'm going to have minus x raised to power 2, okay, all over 2. Then that will be a constant plus c. Okay, since 2 is from both sides, it will cancel out. So I have y squared is equal to minus x. Okay, so apply the initial value, right? I have x equal to 3, then y is equal to 4, right? So I'm having 4 square is equal to minus 3 square, right? Then plus the constant c. So now this is going to be 16, right? Excuse me. This is going to be 16, and of course this is going to be minus 3 square. Okay, of course that will be plus 9. That will be 9, right? Plus c. Okay, plus c. Okay, so here we go. So definitely c is going to be equal to 16 minus 9. Okay, so that's should be 7. All right, so I have solved the initial value, so I can now write my equation now, which is now y square, okay, equal to minus s square and plus 7. So I hope that is well understood. Okay, depending on if it's an objective, depending on the way the finance is being expressed, okay, you can actually solve simplify it to the lowest term. Okay, I think okay, here we go. So I can, from what I see here, from what I see from the option, there's an option here. Okay, so that simply means that I have to collect, this is going to be y square, right? Minus s comes over, that is s square equal to 7. Okay, okay, so it's still another way of expressing it. Let's solve the next question. Okay, let's solve the next question. All right, so having okay, yeah, okay, I kind of make mistake here. This is minus then s square, so this was supposed to be, the minus supposed to still be here, right? So I take the minus to the other side of the equation, that's going to be plus 9, and if I add that, that's supposed to give me 25. All right, okay, so invariably I have to correct that to 25. Okay, so effect the correction 25. Okay, here we go. I want to solve another question. Okay, still on initial value problem of separable ODE. Okay, remember all this ODE, separable ODE. So I bring another question here. Now we've solved this before. You just for us to introduce the initial value into it. Okay, from the initial value I can simply say that, okay, when x is equal to 1 over 4 pi, then 1 over 4 pi, then y is equal to 0. And of course, you know what we do here, just divide the x. Okay, it's equal to 1 plus y square, right? Okay, so cross multiplying, and of course you're arranging the equation, or you have that if I separate the variable, I'm going to have 1 plus y square, okay, with respect to the y, is equal to the x. All right, and Let me separate this. So if I should integrate both sides, okay, I'll have the integral value of 1 plus y square, okay, dy, right, equal to the integral value of the x. So this is gonna give me tan inverse of y, and of course if I integrate 1 dx, that is x, then I'll bring on the c. All right, so from here now I can simply say that, okay, y is equal to tan the tan of x plus c, the x plus c. All right, so now we have to put the initial value problem. All right, y is equal to 0 when s is equal to pi all over quarter pi, right? That's pi all over 4. So y is equal to 0 at the time where it's gonna be when you have tan pi all over 4, right? Okay, pi all over 4, then plus c. Okay, so invariably now pi all over 4 plus c is going to be the tan inverse of 0. Okay, so let's just get the tan inverse. Use calculator, get the tan inverse of 0, make c this the subject, and of course you put it back in that equation and it's good to go. Okay, so this is initial value problem. Okay, and we actually applied the initial value problem for our separable ODE, right? So we are going to be looking at how to solve non-separable ODE in the next video. All right, see you in the next video. Thank you very much.